Okay, so yesterday we left off with, okay, hood please. We're asking nicely.
Yes, sir.
Okay. We left off with watching that video on production of gasoline. Okay, so that's on today's schedule. And let's see here. A couple of reminders. We have an evaluation on Thursday. So if you don't have your vocabulary done, you still have time to get that completed before we actually take it on Thursday. So what are some other products that we receive from petroleum or crude oil? We'll be talking about that in just a moment, but what might you remember from that yesterday? Well, gasoline's the major product because that's what we spent the most time on, but what else could we get from crude oil?
I don't really remember.
Well, if your vehicle doesn't run on gasoline, it must run on what instead?
Electricity.
What fuel?
Diesel.
Diesel fuel. Okay.
Yes, sir.
And you also have what might be lighter than diesel, but heavier than gasoline.
Propane.
No, propane's too small.
Oh,
Kerosene was one. So what are the lightest hydrocarbons? What are our lightest hydrocarbons? Just a simple question.
I don't think anybody knows.
I'm sorry, is that funny though? We're laughing about that. I don't.
Being honest.
Okay, well, I'm just being honest. No one in here knows the lightest hydrocarbons.
No, sir.
No.
Okay. Well, what is one carbon in length? Methane. What's two carbons then? So we do know this then. All right.
One person knows it.
Well, and if that's the case where just one person knows it, is it worth our time to go over this then?
Oh, yeah.
Okay, let me rephrase that. That's a yes or no question. Is it worth our time to go over that? Okay. All right. So, moving forward then. So this is what we saw with that power distillation. Those lighter hydrocarbons, okay, they just get separated out because they turn into a gaseous phase. That's why it's called power distillation, okay? So we'll be going over what you see here on the left-hand side here in just a moment. That would make reference to this distillation that we're talking about. our goal is to get through this and start talking about amino acids with a brief review. In case you're wondering what it is we're getting done, for those of you tuning in at a later time. Okay, does everyone have this content that wants it? Okay, so we need to get through 1. Don't worry, I'll come back. 2, 3, 4, 5. Okay, so yeah. Okay. And one of the aspects that we see here is what allows transferring propane such a valuable tool, because one, it's in a gaseous phase when it's under pressure, because for anyone who's shaking a propane tank, it sounds like there's liquid in there. Okay? I had that backwards. It's liquid when it's under pressure, but once you relieve the pressure, it turns into a gas. So that's one of the unique characteristics, and that would be something significant you might want to know when it comes to the products that we get from distillation. So then we'll look at some of these characteristics that you see here. Again, this is the fractionating tower here, and then we'll make sense of this in just a moment. Okay. Luckily, there's not a whole lot to write for some of these, so we'll be able to get this content in. If there's one aspect I wish that we could perhaps make more of, that would be that of asphalt. And as far as traveling on these roads is concerned, besides gravel, okay, what 2 options do you have to drive on? So we said gravel is one, so asphalt must be another, but what might the third substance be? Yeah, concrete. I'm glad you didn't say cement, because that would be incorrect, wouldn't it? Because cement is actually an ingredient that goes into concrete, okay? But one of the things that can happen, and you say your family owns a construction company. Do I understand that correctly?
I don't know. Do you understand it correctly?
So that's either yes or no.
I think he said yes.
You know? Oh, okay. Well, how come he's answering that? Just
You said, do I understand? I don't know if you understand or not.
oh, okay.
Like
And
when you ask us if we understand content, like you don't know if we understand
Okay, that's why we check. Okay. All right. So, moving forward then. I would just like to try to, let's say, relate this content to what might be important to everybody in here. That's all we like to do. Or that's not all we like to do, but I think that's an important aspect to add to it. So then, when it comes to that of pouring cement to make concrete, what problem perhaps arises when you put rebar in there? Okay, so when these roads get extremely hot, of course, what does the metal tend to do inside of this concrete? With any type of, it won't melt. Okay, it starts to expand, and then what happens is sometimes the interstate can start to buckle. So then once it does that, well then unfortunately you got to shut it down and chip some of that back out of there and level it out, which is rather unfortunate. So maybe we'd be better off just having our roads made of asphalt. But my guess, my best guess would be it's just not as cost efficient as that of concrete. So we've got this one, and then we'll get into the biological compounds here in just a moment. One of the things that we had shown to you earlier is if we stop drilling for oil, okay, a lot of the things that we need for our daily lives, like plastic, okay, we're not talking about plastic bags that you would per se get over at Dollar General or maybe you're over at Sunshine in Madison, okay? Plastic is just something that we can't live without. But the unfortunate side of plastic is what, in your best guess, what's the problem with plastic? When it goes into the garbage, what happens? Thank you. What's wrong with plastics? Just guess.
It's bad for the turtles.
It's bad. Okay, provided it gets out to the sea, but so how has it made it that far though? Wouldn't it have broken down by that time?
It's not biodegradable.
Yeah, right. That's right. It's not biodegradable. It does not break down. That is the problem with plastics. But yet it's something that we cannot live without. Okay. Okay. So then last one for petroleum. Then we'll move on to amino acids. All right. So what we'd like to go over here quickly is, I just think for the average person, they just don't understand why it is that gasoline costs so much as what it does. So if this is a fractionating tower that is pumping oil in here and you're adding a whole lot of heat to this, okay? So according to what you might, your limited knowledge of this, okay, from what we've talked about in class, okay? So if we had these choices, we don't want to put that. So I'll put dashes next to these so we can tell the difference. That's not right. And finally this. Okay, so notice we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 choices. The question that was answered a long time ago is way up here in the top are the lightest hydrocarbons. That would be methane, ethane, and then 3 carbons is propane, okay? And then 4 is, okay. And then once you get some of these heavier compounds, okay, the 5 to 8 range, okay? And I think there's an E on there too. So which one, would you want to start at the bottom and work up or start at the top and work down? Okay? So then which one of these would possibly belong on top? It's about the 6 to 8 hydrocarbon range. So what do you run high efficiency what in your automobile that might not be electric and it's not diesel? Yeah, octane or gasoline, okay? So we have octane, okay, or gasoline, okay? So then we can cross that off, okay? What might, yeah. So what might the next heaviest one be? With what's left? That's a little too far. Oh, no, that's way too thick and too heavy. Kerosene. Okay? Okay, and cross that off. Okay? Lubricating oils would not be right. No. Okay? It'd be diesel. Okay? Wait a minute. I don't think that's right. I think you were right.
He knows his stuff. He got the legend.
It is diesel. Okay? Now you have your lubricating oil.
Then tar.
That's right.
Then tar.
Oil and then tar. Now we've got all them crossed off. Okay. So, yes, we understand that there's a lot of products that we get from this, but then on every plate on this, you have to be able to receive that compound out of there, whether it's heavy diesel fuel, lubricating oil, or gasoline. Again, that's why the productivity of this is so expensive. Okay. Just want to do a brief introduction. We've got amino acids. Or should we save that for your friends when they come back?
It could be better so they could know it better.
Okay, we can do that. All right. So then, okay, this is blinking, which is telling me, just a moment. Now we got some sound back. Okay, so we can get rid of this now. Okay, so some of the concepts that we've been talking about. What is everything that you can tell me about this top compound?
It's a 7.
Okay, so then just like every other time, you want to find the longest continuous chain, which you've identified. Okay, so the prefix for a 7-carbon compound is what?
Pent.
That would be 5.
Benjamin.
Oh, my bad. Heptane.
Okay,
Sorry.
we can do that. Can we put an E on the end?
No, we
Yes.
cannot.
No, we can't.
You're correct, we cannot.
Yeah.
So now that we know that you can't, what must that be because of this? Close.
OL.
OL.
We were close.
Okay?
Oh, I agree.
So one of the things, we could just leave that as heptanol if that's what we had.
Yeah.
Okay? Because it's just understood that this is on which carbon.
The first one.
Right. But that wasn't on the first one. It was over here. So the last thing we need to do is what? Indicate the number,
Which carbon it's on.
yes, of which carbon, and that is which one. Okay? Now, we don't have anything written after that 3. Okay? So that means one of two things. Either it's where the organic family is located, which can mean, in this case, a hydroxy group or OH, or it means where a double bond is located. So we don't have a double bond here, so it's just indicating where that alcohol or hydroxy group is located. That's because that's why the suffix is OL. Okay, so how could we change this heptanol to heptanoic acid?
We could have an oxygen double bond.
Okay, so do we need this? Can we leave this OH here?
No.
No, we cannot. Are we still going to keep an OH though?
Yeah.
Yes, we are. So now, how do we change this organic? So now we just have this as heptane again. So how can we change this to heptanoic acid?
Put an OH on the first carbon.
Okay, so that OH that we had here, we're going to put all the way over here, which is fine. Okay,
And then a double bond with oxygen.
right. And a double bond oxygen. You can put it on the side, you can put it on the top, doesn't matter. So, should we have erased that hydrogen atom? Okay. So how many bonds does carbon want? Okay. So here we got 1, 2, 3, and 4. The reason this maybe looks so different is because typically we would write it like this. So we said put it on the bottom. We're going to move it over to the side now. And then it's probably a little more familiar. Okay. Now, how do we change this to heptanoic? Yeah, OIC. Heptanoic acid. Okay. Okay. All right.
Is that cool?
No, when I hear that, okay, I just let it slide, but in a manner, yes, that is hilarious. I'm being serious. You know why? Shrek 2.
I like Shrek.
What about Shrek 2? What is
that.
yes. So yes, I know it has its place, and I think that's hilarious, but we just let it slide for a couple times. We're not always evil on this side of the desk that maybe we're perceived. Like,
No, I don't
again,
see that.
okay, see, hopefully we're not the enemy here. Okay, we're on your side.
An ally.
Okay? Now, but yes, that is very funny. But anyway. So, what is it that we can change now? Okay? This might look confusing, might look difficult, but let's base this off of old knowledge. We had benzene, okay? Now, what is significant about having Br on there? What column is bromine in?
7.
Right, it's in the 7th column. So, even from prior knowledge, chair down please, from prior knowledge, why is it that being in the 7th column is so significant? Because that tells you something. What about it though? Yeah, how many valence electrons does it have? You answered it already. Yeah, it has 7. Okay, so this isn't the only halogen we could put on here. What else could we put on there? You could put iodine, chlorine, fluorine. Any one of them there are halogens. So with this, okay, we already had established what is this parent compound. Okay, what was, okay, so it was benzene. That's right. Okay. Now, what was branching off of this benzene ring? Okay. So then, okay, do we need to have any numbers on there?
Yes.
This is a trick question.
No.
We do not.
Do you have to put cycle?
No, because that's already established when you have this name. Because before this was established, yes, you probably would have to. You could do this. These mean the exact same thing, okay? But it's just more convenient, it's a lot simpler, and it's a lot easier to write this as benzene. Okay, now, the reason that you don't have to have a number there is we always come back to the same example with sulfuric acid, because I think it makes the most sense. Okay, that means you have 2 atoms of hydrogen, 4 atoms of oxygen. How many atoms of sulfur do we have? Yeah, correct. So does that mean we put a 1 here? No, it's just understood. So therefore, if you only have 1 halogen branching off of there, it's just understood that it's on the first carbon. Should you do something like this then, okay, now once you have 2 derivatives off of there, now you have to number them. And what would the lowest possible numbers you could use? If this one was number 1, which you can do this, there's nothing wrong with writing 1-bromobenzene. That's just being maybe a little too specific when you don't have to, which there's nothing wrong with that. But once you put another derivative on there, now what must you do? 1, 3. You need to establish wherever the lowest number is, which you can do this one as 1, 3, this one as 1, 3, depending upon which way you want to go, clockwise or counterclockwise. Okay? Then, since there's 2 bromine groups on there, you need di on there. Okay. All right. So, now hopefully we're getting some traction and some understanding of this. Okay. It's not that we're running short on time. We're up to 30 minutes already, which I think is perhaps a good place to stop. Is there anything that you could ask that you think is important to you pertaining to this that would help your classmates? Any questions you would like to ask with anything that we've covered today? It's not a trick question. Oh my God, we're gonna have a pop quiz or anything like that. No, we're not. We're not talking about that. Is there? So let's just reflect quickly upon what we've learned so far. What are our three? If we have alkanes, we've learned those. What else have we learned? Alkenes. What else have we learned? Okay, alkynes. Okay. What other organic compounds have we learned? We've learned alcohols. Okay. What about this up here? Okay. And we're just going to say organic acids. Because technically you'd say sulfuric acid, but that's not an organic acid like this. Okay? We've learned this. Okay? Because that is, two of these perhaps look familiar over here. Okay? Anthracene, we learned that. Okay? Phenanthronine, we've learned that. Okay? In case you're wondering, the one that's not up there that we have learned, we got two benzene rings here, but what happens when you put them next to each other? It's not up here. It smells like mothballs. Starts with an N. Does that maybe jar your memory? I'm willing to bet that if you look in your notebook, if you wrote them down, I bet it's in there. What's that called? Naphthalene. Then when you put three of them together, that'd be this bottom, or no, sorry, this top one, anthracene. So now if we're really good, you might have wrote down what it's actually used for. What sticks out in my mind is your Flandreau wrestling sweatshirt and our Duke basketball. I'm just presuming basketball. Yeah, because it's a compound needed for dyes to be taken into clothes, okay? And then this is content that you learn. We take this in a slow progression. You get an introduction here. Then we go a little further in depth, as you can see with general chemistry. Then for those of you who take organic and biochemistry as a senior, then you just go further in depth. Okay, I think that's enough. So tomorrow we will start talking about these amino acids. Evaluation on, down please. Chair down, please. Thank you. And then you have an evaluation on Thursday, and then we'll probably start talking about sugars on Friday. Next week, we're going to start reviewing for not just a problem, your second problem quiz, but also your exam over this. Then the next week, we'll start reviewing. So we're starting to wind down fairly quickly. Okay, we'll catch up to you next time.